I'm John Cook from the University of Queensland. I'd like to talk about how to respond to climate science denial. We know that there are a number of contrarian organisations and media outlets that produce and disseminate misinformation about climate change. We also are familiar with many of the myths and arguments against climate science and against climate solutions that are designed to manufacture doubt about climate change and climate action. But what do we do about it? So I'm going to talk about two things. Firstly, what is the impact of denial? What impact does misinformation have on people's attitudes, on their beliefs about climate change? And secondly, what do we do about it? What does the psychological research tell us are the most effective ways to respond to misinformation and to neutralise climate science denial? To start off, I'd like to talk about an issue that's close to my own heart, the scientific consensus on human-caused global warming. A number of studies, including a paper I published in 2013, have found overwhelming agreement among climate scientists that humans are causing global warming. This statistic, the 97% consensus, matters because what people think about scientific consensus has a big influence on a range of attitudes and beliefs about climate change. Psychologists have identified perceived consensus, what people think about expert agreement on climate change, as a gateway belief. It influences a whole range of other climate attitudes and beliefs. So what people think about expert opinion on climate change affects whether they think global warming is happening, whether humans are causing it, whether global warming is dangerous, and most importantly, it affects people's support for climate policy. So that means that if people are confused about the level of scientific agreement on human-caused global warming, they're less likely to support action to mitigate climate change. And this makes a lot of sense. If you think that the scientists don't agree that humans are causing global warming, well, we should wait and see, we should wait for them to work it out before we bring in policies to mitigate climate change. Opponents of climate action have recognised the importance of perceived consensus for decades. Back in the late 1990s, a Republican pollster, Frank Luntz, was advising the Republican Party to cast doubt on the scientific consensus in order to win the public debate about climate policy. In a memo that Frank Luntz wrote in the late 1990s, he advised Republicans, should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate. And the Republican Party listened to Frank Luntz. Now, Republicans have been accused of denying science or ignoring evidence, but in this case, they followed the market research of Frank Luntz and they focused their attention on casting doubt on the scientific consensus on climate change. An analysis of conservative opinion pieces published over 2007 to 2010 found that the most common myth, the most common argument against climate change by far was there's no scientific consensus. So conservatives have been attacking the consensus. It's been one of their primary focuses in their efforts to delay public support for climate action. Now this strategy has been effective. Although there's 97% agreement amongst climate scientists that humans are causing global warming, when you ask the public what's the scientific consensus, the average answer is around 67%. So there's a huge gap between what the public think and the actual 97% consensus. And as the gateway belief research indicates, this gap, this consensus gap matters. So what do we do about this? Well, one key thing is communicating the scientific consensus on climate change. So this is something that we've been doing at Skeptical Science. We've been working hard at communicating the 97% consensus to the public. Now this work started with a paper that we published in 2013 that quantified the level of agreement on human-caused global warming in published climate research. At the same time that we published this paper, we also published a website that summarised our results in a very user-friendly, visual, simple manner, making the research as accessible to the public as possible. Our goal with the website and our communication of our research was to make the scientific consensus as sticky as possible. So we included a bunch of infographics that made it easy to share, and we boiled down all of our results from our paper down to a single number, 97%. Making the results of our paper as simple and sticky as possible led to our 97% consensus being picked up by a range of public figures.
A survey of thousands of scientific papers that took a position on climate change found that 97% endorsed the position that humans are causing global warming.
Some 97% of scientists who have written in peer-reviewed journals say the following: climate change is real, it is significantly caused by human activity.
NASA says that 97% of climate scientists agree that the warming we're experiencing is very likely due to human activity.
97% of peer-reviewed climate studies confirm that climate change is happening and that human activity is largely responsible.
97% of climate scientists agree that climate change is real and caused by people.
97% of scientists the world over have said that climate change is urgent and man-made and must be addressed.
97% of scientists, including, by the way, some who originally disputed the data, have now put that to rest. They've acknowledged the planet is warming and human activity is contributing to it.
Accompanying all the positive attention that our research and the 97% consensus got was a whole bunch of negative attention and criticism as well. We anticipated a lot of this criticism. On the day that our paper came out, we also published an FAQ anticipating many of the objections and criticisms of the research. But being targeted in a focused manner by the denialist machine is a bit like the Matrix. You can't be told what it's like, you have to experience it for yourself.
This 97% figure has been repeated over and over and over again by such a wide variety of people.
The 97% figure that's thrown around, the head of the UN IPC said that number was pulled out of thin air.
A paper came out in a journal which I suspect was created just so that they could publish this paper.
97% is bogus. The stat about the 97% of scientists is based on one discredited study.
This might be a good time for me, without objection, to put into the record an article from the Wall Street Journal 3 days ago, May 26. The headline is "The Myth of the Climate Change 97%.
That 97% number, that's been debunked in several studies.
This 97% is essentially pulled from thin air.
That 97% figure, like so much else in the science of global warming, is the subject of vigorous debate.
97% of all scientists believe...
Is this a bogus number?
It's so not a bogus number.
It's so a bogus
Okay, yours is, mine is, yours is, mine is.
Oh, well, I guess if 97% of all scientists believe that man's activities are creating changes in the weather, who am I to question that?
All this negative backlash is important. An upcoming study by Sander van der Linden from Princeton found that misinformation can be disturbingly effective in cancelling out the effect of positive, accurate information. This graph summarises an experiment from van der Linden's study. Now, the left bar shows what happens to perceived consensus when you tell people about the 97% consensus. And what we find is telling people about the 97% is highly effective. It increases perceived consensus by around 20%. So consensus messaging, just communicating that single number, is highly effective in raising perceived consensus, which is an important gateway belief. However, in the real world, as I've just shown with those videos, people aren't just exposed to positive, accurate scientific information, they're also exposed to a whole range of misinformation. Now, in van der Linden's experiment, the right bar here shows what happened when people were exposed to conflicting information. They were shown both the 97% consensus, but they were also exposed to misinformation casting doubt on the consensus. And what they found was the two conflicting pieces of information cancelled each other out. This result has big consequences for science communicators, not just in climate change, but in any area of science. It tells us that even if we get our science communication perfect, if it's simple and sticky and follows all the rules of good science communication, all of that good work can be undone by misinformation. Our accurate science communication can be cancelled out by misinformation. So what do we do about it? The standard approach that science communicators take is to explain the science. And to use a metaphor, it's a bit like taking vitamins. Now, we take vitamins to address deficiencies. We might be deficient in a particular mineral. So we take vitamins to address that deficiency. Similarly, when we explain science, we're trying to address deficiencies in people's scientific understanding. And hopefully by explaining the science effectively and reaching a lot of people with our science communication, we can reduce misunderstandings and misconceptions and improve people's understanding. People can get a healthy, strong understanding of the science. The problem is that taking vitamins doesn't necessarily help us when we encounter a virus. So the way that we protect ourselves from viruses is through inoculation. And the way this works is we build immunity to a virus by exposing ourselves to a weak form of the virus. Now, this works the same with information. There's been over half a century of psychological research into inoculation theory, which takes the idea of vaccination, of inoculation, and applies it to knowledge. And what they've found is that we can help people build immunity, build resistance to misinformation by exposing them to a weak form of the misinformation, by explaining how the science can get distorted. So in van der Linden's experiment, he had a third group where he exposed them to both the 97% consensus and an inoculation message before showing them the misinformation. And what he found was the inoculation was successful in mostly neutralizing the negative influence of the misinformation. So what do I mean by inoculation? How do you expose people to a weak form of misinformation in order to help them build immunity to the actual misinformation? Let me give you an example. I ran an experiment where I exposed people to misinformation, and then for another group in my experiment, I exposed them to inoculation before the misinformation. The misinformation was verbatim text taken from the Global Warming Petition Project. This is a website that has a list of over 31,000 people with science degrees who have signed a petition. They've signed this statement saying that humans aren't disrupting climate. Now, anyone with a science degree is qualified to be on this list. So I showed people this misinformation, just a short excerpt from the Global Warming Petition Project website, and then I measured their perceived consensus. So this graph shows the change in perceived consensus. The dotted line is 0, no change in perceived consensus. So anything below the dotted line means that their perceived consensus went down. Now, the horizontal axis in this graph is political ideology. On the left, people are more liberal, more left-wing. On the right, people are more conservative, more right-wing. And what I found was the misinformation had the greatest effect on conservatives. Conservatives lowered their perceived consensus by around 20%. And overall, there was about a 10% reduction in perceived consensus. So the misinformation did have a statistically significant effect in lowering perceived consensus. For another group, I showed them an inoculation text before showing them the misinformation. And this is an excerpt of the inoculation text. Now, what I did was I explained to them the technique of fake experts, which is the technique of using spokespeople who have the appearance of expertise, but aren't actually conducting scientific research in that specific area. So I used the tobacco industry as an example of the fake experts technique. Now, back in the 1970s, the tobacco industry ran a number of ads where they listed tens of thousands of doctors who endorsed a particular brand of cigarette or claimed that smoking didn't cause lung cancer or talked about how smoking soothes the throat. And these doctors had the appearance of scientific expertise, and yet they weren't conducting any actual scientific research into the health effects of smoking. So they were fake experts. So after explaining this technique of fake experts and giving them an example with the tobacco industry, I then joined the dots between that and what was happening currently with climate change. I didn't specifically mention the Global Warming Petition Project and their 31,000 scientists. I just spoke in more general terms about the technique of fake experts being used to cast doubt on a scientific consensus. The blue line in this graph shows the change in perceived consensus amongst the group who were shown an inoculation before the misinformation. And what we found was overall there was no statistically significant effect. The misinformation had no effect on people's perceived consensus. It was completely neutralised. So pulling all the psychological research together, there are three elements to an effective debunking, to an effective response to climate misinformation or to any form of misinformation. The most important thing in a debunking is the facts. You still need to communicate the science as clearly as possible and communicate the science in a sticky manner as possible. Make your science simple and concrete and tell stories, grab people's attention, make your science memorable. But as well as explaining the science to people, we still do need to mention the myth. Now, one important technique before mentioning a myth is to warn people that you are about to mention a myth. And what this does is it puts people cognitively on guard so that they're less likely to believe the myth, they're less likely to be influenced by the myth. And when they hear it, they instantly tag it in their minds as misinformation. And then what you've done after explaining the facts and the myth is you presented two conflicting pieces of information. And as we saw in van der Linden's research, this has a danger of cancelling each other out. Now, the way that you help people to reconcile these two conflicting pieces of information is explain the fallacy that the myth uses. Explain the technique that the myth uses to distort the facts. And once they understand that fallacy, then they can reconcile the fact and the myth. To give you an idea of what this might actually look like, I'll give you a few practical examples of how I've applied this fact-myth-fallacy format in real-world examples. Now, I found one way that I can actually get published in conservative newspapers is wait for them to attack my research. And when they do, I request a right of reply. Now, at one point, the Financial Post published an article or an opinion piece attacking our 97% consensus paper, and so I requested a right of reply to respond to that opinion piece. So this is my response, about 1,000 words responding to this article criticising our research. But what I did was I structured my response in the fact-myth-fallacy format. Now, most of the article was communicating the facts, communicating the overwhelming 97% consensus on human-caused global warming. And I started the article with the facts, the headline communicated the facts, and I concluded the article reaffirming the facts of the consensus. But I also had to address the misinformation in the article criticising our paper. So after introducing the facts, then I brought up the key myth from that criticising article. And then once I'd explained the key facts of the consensus and mentioned the myth from that article, then I explained the fallacy that the myth used to distort the facts. So writing that right of reply gave me the opportunity to inoculate Financial Post readers, a conservative audience who typically aren't exposed to messages about the 97% consensus, and really inoculate them against the misinformation that they would typically read in their newspaper. Another example of the fact-myth-fallacy approach was a response we published to a criticism by Professor Richard Toll. He criticised our 97% consensus paper and claimed that our 97% result was an outlier compared to all the other studies into scientific consensus. So we published a response in Environmental Research Letters, and at the same time we published an online video. In our video we summarised the key results from our paper. And what our paper did was it synthesised all of the research quantifying the level of scientific agreement on human-caused global warming. What we found when we surveyed all the different estimates of consensus was not only that there was an overwhelming consensus amongst experts, but we also found that as expertise increased, we also saw scientific agreement increase. Now, this relationship between consensus and expertise has an unfortunate consequence, It means that it is possible to find scientific groups who have less expertise in climate science and consequently also have less scientific consensus, and use those groups to argue that there's no consensus on climate change. Once again, this is the fake expert strategy that we also saw in the global warming petition project. This was the technique that Richard Toll was using in accusing our paper of being an outlier. So in our video, we explained a key fact that as expertise in climate science grew, so did scientific consensus. But we also explained the technique of fake experts used to cast doubt on this high level of scientific agreement. And lastly, the most prolific example of the fact-myth fallacy format in my work is a massive open online course, or MOOC, titled Making Sense of Climate Science Denial, or Denial 101X. Now this MOOC was published in 2015 on the edX platform, and what we did was we debunked around 50 of the most common climate myths. And each video, each around 7 minutes long, used the fact-myth fallacy format. So all of our lectures went through the facts of climate change, the fact that global warming is happening, humans are causing it, the impacts are serious, and then we looked at a single myth associated with each climate fact, and then we identified and explained the fallacy that each myth used. So the MOOC inoculated people against 50 of the most common climate myths about climate change, and it also explained the key facts of climate change as well. So here are some future steps that I think need to build on the work that's already been done. While Skeptical Science and the Denial 101X MOOC have made a good first step in building lists of common climate myths, there needs to be a more scholarly, comprehensive analysis of the type of misinformation that's published in conservative think tanks, in climate blogs and in mainstream media and other outlets. We need to look at what myths are being published and how do those myths change over time. By better understanding the trends of misinformation, we can anticipate what misinformation, what claims are going to grow more popular over time and plan our communication accordingly. Once we've built a comprehensive list of contrarian claims, we then need to identify the fallacies, the techniques used in each claim. What's involved in this effort is pulling apart each claim to identify the argumentative structure. What are the premises? What are the conclusions? And once you've got that argument structure, you can then identify the fallacies. And often there are more than one fallacy within a single claim. We need to conduct psychological research into how to more effectively inoculate against misinformation. There's only been a number of studies into inoculation and even into debunking against climate misinformation. So we need to experiment with different structures of debunkings and different ways of framing the content in order to find out what are the most effective ways to neutralise misinformation. Can identifying the fallacies and improving critical thinking, does that work on all audiences? Does it work more effectively with different types of audiences? There's a lot of psychological research to be done in this area. And lastly, what we need to do is pull all of this research together and turn it into practical resources for communicators and educators. The Denial 101X MOOC is an example of this. It's really a first step where we've taken all the psychological research into debunking, we've practically applied it in creating all these video lectures, and now we've made all those videos available as resources for communicators and educators. They can be used in the classroom, and a number of classrooms are already using our videos. So that's a brief summary of the psychological research into misinformation and climate science denial. This research tells us two things. Firstly, misinformation matters. Climate science denial can cancel out the positive effect of accurate science information. And secondly, the way we stop science denial from spreading is by exposing people to a weak form of science denial. We can neutralise misinformation by explaining to people the techniques that the misinformation uses to distort the science. Thank you.